Hi, so in this video we'll make a simple text classification using scikit-learn. So for this example we'll be using a data set called this BBC data set. It contains about 2200 articles and it has 5 different categories. Let's look at the data. Once you download the zip from the link and then extract, you will see the articles are organized into these different folders, into these 5 categories. So we'll make a simple naive Bayes model using scikit-learn and make the predictions from there. So first thing first, I'll keep the link in the description so you can download the dataset. So first of all, let me define the data directory. BBC. Then let's import few libraries that we'll need inline. Then let's import numpy, snp, lib.pyplot as plt, just in case we plot something. Then datasets, import load file. So this function will help us load the dataset that on this format. So it expects each class to be in a separate folder, which we already have, so it's a handy function that we can use. So data equals to load files, then from where? From data directory. Then we just want encoding to be UTF-8. Then in case of any errors while decoding, we'll just say replace, so that it doesn't throw us any exceptions when we run it. So we already know how many categories are there, 1 2 3 4 5, but yeah, just for the sake of demonstration, I will show you how you can view all of those. So first okay, this is still running. Okay, anyways, we'll see how many articles are there per category. So for that we'll use calculate count of its category. So this would be labels counts equals to np.unique. There's this unique function provided by numpy, and we can just pass this data.target. Then we want this return counts to be true, so that we get the counts associated with each category. Then we want let's just print labels and counts, see what it is. So labels is just 0 1 2 3 4, and we have the counts, but this scikit-learn automatically converts the name of the classes into these numeric indices or index, but let's just convert these to string labels. So for that we need labels str equals to np array. Then the target names or the classes are saved as target names in the data. This is done by the load files function automatically. And then labels, then let's create a dictionary out of this. So print dict zip labels str and then count. So this is basically creating a dictionary by zipping the string labels and counts. So we'll get something like this. So for politics we have 417, for tech related is 401. So All in all, they look okay. I mean, all of the categories have some decent amount of samples, and none of them are heavily not quite imbalanced, I would say. So I think this would work pretty good. So before we can make a model, what we need to do is convert our text data into some sort of vector representation, and for this particular purpose we'll be using something called TF-IDF. So for that, let's create a heading, data preparation. So first we'll split our data into training and testing set, and then we'll do the things as vectorizing the text. So from sklearn model selection, we import train test split. So this function will divide the data set into training and testing set, and we can also specify what percent of the total data set we want to assign to training set and what for the testing set. So let's just say x train, x test, y train, y test equals to train test split. So the data is in this data property, and then the classes are in data dot target. So by default it will split 70% of the data will go to the training set and 30 will go to the testing set. So this is the format that this train test split will return. So x train, x test, y train, and y test. And let's also see how many samples we have. Something is wrong. So we have 1600 for training and 550 for testing. So before we vectorize the text, what we need to do is tokenize the text into words. So basically tokenization means converting these articles into words. So basically this would be one word, this would be another. So first we need to tokenize, then what we need to do is convert all of these letters into lowercase, so that the word like this capital the and this capital the this the and this one are the same. So here the T is capital, but here in this the all of the letters are small. So if we don't convert them to the same case, then these would be considered as different words. So we don't want that. That's why we usually convert to lowercase, but yeah, we can also do the uppercase. And then we need to remove some stop words, or basically the words that are not important. For example, the word like the or of or an or something like that. And the next step what we will do is stemming. So basically stemming means removing this for example, in case of investors, after stemming it would become invest. So going back to the root of the word, so biggest would become just big. So, and after we have done all of those, removed useless words and done this stemming and a few others, then we can finally convert these in the whole text into a vectorized form. So let's go through the steps. from sklearn dot feature extraction dot text df idf vectorizer. So we use this one to vectorize our text. So vectorizer equals to df idf. Then what we want to do is, so here are a lot of parameters that we can pass, but for this we'll just assign stop words to be for English words. Scikit-learn already provides, or you can also supply your own stop word list here. And then we also want max features to be, let's for this demonstration I'll just use 1000. So what max feature means is it will take the top 1000 most frequent words and only consider those, and all the other words that are not seen in the top 1000, it will just replace it with some kind of unknown token. This we should try to keep as small as possible, because we'll see later that the bigger the size of these features, the more bigger our metrics will be, the training data or for testing or training. So yeah, we should try to keep this number as small as possible, while also in the maintaining the accuracy that we want. So again we'll just say decode error ignore, then vectorizer.fit extend. The reason we splitted our data into training and testing set was so that we can so that we can use only our training data to train this vectorizer, so that the vectorizer only sees the text what was provided in the training set, and it will only consider the words that was seen in the training set. We cannot it's not good idea to include all of your whole data set to train this vectorizer. So once the vectorizer is trained, now we can build the model. So let's build model. So we'll just use a simple naive Bayes. So from sklearn.naive Bayes import multinomial NB, then we'll just use the default parameters whatever they are. Now cls.fit. For this fit function we need to pass a vectorizer.transform and xtrain y-train. So first we'll use our vectorizer to transform whatever was in the xtrain. So all of our text would be vectorized and then passed into this classifier along with the labels. So now this is trained, our model is trained. Let's see how it performs. So we'll just import a couple of helper functions from sklearn.metrics. We'll import classification report and then accuracy score. So we'll predict on our test cases. So x test, then print accuracy score. For accuracy score needs this the actual levels and what was predicted by our model. So by print, then also we'll print classification report with same thing, y test, y pred. And we saw that okay, this our model achieved a 96% accuracy in test set, and in this classification report we can see that these are the categories 0, 1, 2, 3 and 4, and we get more information rather than just the accuracy. We get all of this precision, recall, F1 score. So the model looks good. It could definitely be improved. Like for example, even though we talked about stemming and all, we didn't do any stemming. So we could also in this vectorizer there is a function tokenizer or preprocessor. We can add more our own custom function to do all the stuff. But yeah, for now, for this demonstration, even with this simple pipeline, we managed to achieve 96% accuracy, and it's not too bad. So in the next video we'll look at how we can use grid search of sklearn to find the best parameters for our models. For example, here in multinomial NB we just used the default values, whatever there was, and also in the TF IDF vectorizer we just said okay, we'll use max features 1000, but who knows, maybe using 2000 would have made the accuracy even better. So in the next video we'll look at how we can automatically tell the sklearn to try out different values for these parameters here or here, and give us the best values that would make the best performing model, or in other words, that the model that gives the highest accuracy. See you next time.